Hello, everyone. My name is Zachary Meggett. I'm from Baltimore, Maryland. I'm a first year marine and environmental science major, and I served as the data collector in this group project.
Hello, everyone. My name is Jocelyn Chestnut. I'm a first-year bio pre-med from Syracuse, New York, and I served as the co-leader of this group.
Hi, my name is Aviana Boston. I'm a first-year biology integrated major from Reading, Pennsylvania, and I served as the library manager.
Hello, everybody. My name is Tyson. I'm a first-year biology pre-med major from Connecticut. And today we are going to talk to you guys about how time of day influenced the overall migrational patterns of birds of prey. Now, starting off with our introduction, we wanted to overall give a perspective into what migration was. And from that point of view, we then branched off into understanding and comprehending what the bird population was and how it impacted our overall case. We wanted to prove and help everyone understand how population related to time of day and how those factors impacted everything. The purpose of our overall research was to determine what time of day was and how it affected and impacted the travel patterns of the birds of prey. And our objectives was to find the populational patterns within the data given and provided. And we also wanted to address how time of day relates to migrational patterns.
The species we encountered while doing this experiment was the American crescent, the bald eagle, the broad-winged hawk, the Cooper's hawk, the golden eagle, the merlin, the Mississippi kite, the northern goosehawk, the northern heron, osprey, the peregrine falcon, rough-legged hawk, red-shouldered hawk, red-tailed hawk, sharp-skinned hawk, Swainson hawk, shallow-tailed kite, unknown accipiter, unknown falcon, and unknown raptor.
Our null hypothesis birds of prey migrational population patterns will vary throughout various days. Our hypothesis was birds of prey migrational population patterns will be higher in the afternoon in comparison to all the morning months. Our predictions are birds of prey population levels will be higher in the afternoon and lower during the morning.
The methods that we went through were first researching the data site, then collecting data from the months of August, September, October, and November of 2020 and 2021, then plug that data set in Excel, then compared all the data from both years and for each month, and create graphs on the direct relationship between the time of day and rate of migration.
So from the data we collected, we wanted to overall compare both the morning and afternoon to one another, and we used the figures above to do that. So from figures 1, 2, and 3, we were able to overall determine the populational patterns for the 2020 season of Kiptopeke Bay, and we did so by dividing these into 3 different months. So for figure 1, we were able to see that there was minimal change in both the morning and afternoon populational patterns. And we also saw in October that there was minimal change in the populational numbers, the afternoon particularly dominating in the early beginnings of the month, and then overall evening out between both the morning and afternoon. And then during the 2020 November for figure 3, we were able to see that there was close correlation between all the populations, but there were sure outrises in during the 24th of the November month. And it could be accounted for that the gaps in between the population and in between the graphs were due to the days that were not collected upon. Continuing the description of the figures 4, 5, and 6 overall state and show the populational patterns for the 2021 season. During these times, you could also see throughout these points that there was close patterns within the populational numbers, and there were not a lot of outliers or dominance within these patterns. During figure 6, you can see that the morning time dominated over the afternoon time for majority of the month. For the figures that are on the right-hand side of the poster for 7 and 8, we could see that these are both the seasons compared between one another. Figure 7 shows the overall month population for 2020. And then we could also see the birds of prey population in those numbers for 2021. And in comparison, you can see how there are high numbers for October and lower numbers for November, and those are seen in both of the graphs. For figures 9 and 10, we were able to complete a t-test, which compared the overall population and correlation between morning and afternoon. For figure 9, we can see in 2020 that the p-value for the test was 0.85 or 85%. Because the percentage was higher than 0.05% or 5% as a whole, the overall relation between the morning and afternoon showed to vary. Because the number was so high, it showed that there was little to no correlation between the two times. And that is shown also in figure 10 when comparing the 2021 season, based on the fact that the p-value was over 0.05 and was standing at 0.76%.
Our research question, does time of day have a particular influence on birds of prey migrational patterns, was supported by our individual research. The data collected shown that the different types of birds have a high volume of mass migration during the afternoon, where the temperature was more suitable for travel with steady winds and ideal temperature, etc. The overall data vary through populational values and seem to drift according to month rather than correlating with the time of day.
We would like to thank for Hawk Count providing us with the data and Hawk Watchers, as we are unable to do because of COVID restrictions. We would also like to thank Hampton University, Dr. Dash, and the NSF for providing us with support throughout this process.
And that overall concludes our presentation.